This is Welding, your ultimate guide to weld and cut metal. Written by Robert J. Miller. Read by Matt Montanez. Chapter 1. Welding Instruments. Valves. Tank valves. The acetylene tank valve is of the needle type, fitted with suitable stuffing box nuts and ending in an exposed square shank to which the special wrench may be fitted when the valve is to be opened or closed. The valve used on lined oxygen cylinders is also a needle type, but of slightly more complex construction. The body of the valve, which screws into the top of the cylinder, has an opening below through which the gas comes from the cylinder, and another opening on the side through which it issues to the torch line. A needle screws down from above to close this lower opening. The needle which closes the valve is not connected directly to the threaded member, but fits loosely into it. The threaded part is turned by a small hand wheel attached to the upper end, which this hand wheel is turned to the left or up as far as it will go. Opening the valve, a rubber disc is compressed inside of the valve body, and this disc serves to prevent leakage of the gas around the spindle. The oxygen valve also includes a safety nut, having a small hole through it closed by a fusible metal which melts at 250 degrees Fahrenheit. Melting of this plug allows the gas to exert its pressure against a thin copper diaphragm. This diaphragm bursting under the gas pressure and allowing the oxygen to escape into the air. The hand wheel and upper end of the valve mechanism are protected during shipment by a large steel cap which covers them when screwed on to the end of the cylinder. This cap should always be in place when tanks are received from the makers or returned to them. Regulating valves. While the pressure in the gas containers may be anything from 0 to 1,800 pounds and will vary as the gas is withdrawn, the pressure of the gas admitted to the torch must be held steady and at a definite point. This is accomplished by various forms of automatic regulating valves, which, while they differ somewhat in details of construction, all operate on the same principle. The regulator body, Figure 14, carries a union which attaches to the side outlet on the oxygen tank valve. The gas passes through this union, following an opening which leads to a large gauge, which registers the pressure on the oxygen remaining in the tank and also to a very small opening in the end of a tube. The gas passes through this opening and into the interior of the regulator body. Inside of the body is a metal or rubber diaphragm placed so that the pressure of the incoming gas causes it to bulge slightly. Attached to the diaphragm is a sleeve or an arm tipped with a small piece of fiber, the fiber being placed so that it is directly opposite the small hole through which the gas entered the diaphragm chamber. The slight movement of the diaphragm draws the fiber tightly over the small opening through which the gas is entering, with the result that further flow is prevented. Against the opposite side of the diaphragm is the end of a plunger. This plunger is pressed against the diaphragm by a coiled spring. The tension on the coiled spring is controlled by the operator through a threaded spindle ending in a wing or milled nut on the outside of the regulator body. Screwing in on the nut causes the tension on the spring to increase with a consequent increase of pressure on the side of the diaphragm opposite to that on which the gas acts. Inasmuch as the gas pressure acted to close the small gas opening and the spring pressure acts in the opposite direction from the gas, it will be seen that the spring pressure tends to keep the valve open. When the nut is turned away, out there is, of course, no pressure on the spring side of the diaphragm, and the first gas coming through automatically closes the opening through which it entered. If now the tension on the spring be slightly increased, the valve will again open and admit gas until the pressure of gas within the regulator is just sufficient to overcome the spring pressure, and again close the opening. There will then be a pressure of gas within the regulator that corresponds to the pressure placed on the spring by the operator. An opening leads from the regulator interior to the torch line so that all gas going to the torches is drawn from the diaphragm chamber. Any withdrawal of gas will, of course, lower the pressure of that remaining inside the regulator. The spring tension remaining at the point determined by
Sample complete. Ready to continue?